So we're building a blogging system with Haskell and Yesod. It's questionable whether we'll actually get to building a blogging system, but we definitely will be building the kind of things you would use to build a blogging system. And if we're lucky, by the end, we'll have something that starts to resemble a blogging system. But probably not everything that was stated in my description. We'll see. Oh, I left this off. OK. A second ago now. Oh, now I closed it. Technical difficulties. There we go. All right, so I graduated from IU Bloomington a while ago. This year I'm also a volunteer here at LambdaConf, hence the blue shirt. I am in particular the hunger prevention manager. If I'm around at any meals, feel free to grab me if you have any questions, dietary needs, things like that. I also have some assistants who are handling things today because I'm doing this workshop. That's my site, going to GitHub, you can look at these things. I started a company with a friend. We do contracting, whatever. Yeah, attributions. I took a lot from Michael's book because he has a lot of good content there. And we're using stuff that came from the Yesod Postgres stack template, MIT licensed. So just get those out of the way. And just to get a better feel for the room here, wanted to ask just kind of how much Haskell experience people had. I realized a fair number went to this Haskell commercial training beforehand. Is anyone here never touched a line of Haskell? OK, so people have written some Haskell. That's good. And people who here has never made a website of any form?
In Haskell or?
Just in general. Any form, like written any HTML, CSS, JavaScript. OK, but you've seen some HTML, CSS, JavaScript, hopefully.
All the time because I use the web. But
Pre-rendered, though, I mean.
tiny bit.
OK. I mean, I'm trying to keep that to a minimum because that's not what the talk is about. But we're generating that sort of thing, so you'll run into it a bit. But you shouldn't need much, hopefully. So this is kind of a general overview of what we're planning on doing. We're going to jump into a exercise really fast because exercises are good, get people hands-on. I'm not going to explain most of the things in that exercise, but it's going to be really simple, so you're just going to kind of figure it out. But first, we're just going to do some basic background. There are some very common language extensions that we end up using. People who have been in Haskell a little while probably know about most of these. Does everyone know about overloaded strings? Yeah. Wait, does anyone not know about overloaded strings? Maybe I should. OK, great. I can talk about overloaded strings then. So overloaded strings basically lets you use literal strings as types that are not the standard string type in Haskell. Standard string type in Haskell is just a list of characters. But in the real world, you don't really want to represent your text like that most of the time because it's inefficient to use lists for everything. So what overloaded strings lets you do is just makes it more convenient because you can now write literal strings, and it'll automatically call conversions compile time to turn it into your text type for higher performance sort of stuff, or all sorts of various other uses. Now, Yesod uses this in a couple interesting ways, or at least one interesting way, but I'll bring up later. But I just wanted to make sure people are familiar with it. Type families I'm not going to talk about as much because, well, yeah, I'm not going to talk about them as much, but I wanted to just introduce them because they're useful and there's something that Yesod uses again. What type families let you have is have a type definition inside a class instance, basically. So if we have this type class safehead that provides a function to get a head of something like a list, but we want to overload it so that it works on something like a byte string and gives us back the first byte of that byte string. What this lets us do is have the type be parameterized over the instance. And where safehead now returns maybe content, that content type is different if it's for a generic list or a byte string. If it's a byte string, it overrides that to a word 8 rather than just the elements of the list. like all of that.
Flat. Okay, so
Yeah, feel free to jump in though. Like,
okay, yeah, I get all of it. If it's possible, otherwise you can talk.
no, no. So the point here is that
You specialize the state head on the input parameter is like a sort of like in a template, where you can specialize the template depending on which type you get in. You do a little bit different.
yeah, exactly. And for this sort of thing, to give an example, in the Yesod land, we have a type class for Yesod applications that give you a identifier for users, and you can then, it lets you parameterize it lets you basically choose what type various functions give you back, like, get what this person's user identifier is. You can change that as part of the type class. So that lets us have these functions as part of this type class that give, generic functions to get us a user's identifier, but have it be different depending on what identifier we want to use.
So in this case, what's that into the content?
So well, that example was a little bit separated from this example. For this example, it's basically that you want to take heads of lists, but you also want the safe head function to work on things that aren't lists, like byte strings, and get the first byte of that byte string. And for that, we make it so that the return type of safe head with this content is changed to a word 8 rather than the elements of the list that the safe head is, the type class is instantiated on. Okay?
That content type, that's like scoped to say the class.
Is that only available within that?
Yeah, no, I get the question. I'm trying to think of the right way to answer it. So,
I was trying to think of the right way to ask it.
yeah. I believe so. I believe you can't define anything outside that, yeah.
There's also, type, was it like type, I can't remember, you could define a function, but you have to have it all in one place. You can add new instances at any time, just like new insert, it's an open
Right, an open-ended
function.
type class kind of
Right.
deal, yeah. But for this, yeah, I believe it's restricted to that.
Right.
But you're not actually using this hand. I'm just bringing it up so that things aren't confusing if you hadn't heard of them.
It feels like you're kind of allowing for types to be used in the future. Type classes.
Yeah.
Rather than limiting it to.
Exactly.
So
Some particular type or type class or other type class.
Thanks.
So it prevents you from having to have a whole other type class of things that.
So if you have a type class called safe head, and you're implementing a for byte string, byte string, so in this case it will return the word 8 instead of string. So, but for another instance, okay, there, just an array element. Yeah, because the regular type class is so constrained, and it's too constrained for what you're trying to do.
Yes, exactly.
It's almost like changing.
Okay, I'm moving on now. Template Haskell is used rather extensively in Yesod to prevent us from having to type out large amounts of code that we don't want to deal with because it's mechanical code. It's not interesting code. Template Haskell, if you don't know, is code generation in Haskell. It lets you have code that runs at compile time and generates more code, but it is then type checked and used and all that. So
Do you have an example of that?
we'll get there. But this can also do things like load files up from the file system. You can actually do code introspection here. This could actually look at other Haskell code. Yesod doesn't actually really make use of looking at the introspection features though. So, but this is used a fair bit. We'll run into it soon. Yeah.
Could you maybe, I'm pretty new to Haskell, could you maybe just go over syntactically what I'm looking at in that first line?
Right. So this is just a normal function call. You wouldn't have this $paren close paren. This is just indicating to the compiler that it's a template Haskell function.
Oh, okay.
And then this is just saying that since GHC something that I can't remember, it's been allowed that you don't actually have to specify it directly like that if it's at a top level of your module. So
what makes that $sign different than the one that allows you to not include parentheses?
I don't actually know. I don't think I've ever incidentally written $open paren without a space to try to. Well, Actually, that'd be rather silly, right? Because if you're using $ not to indicate parentheses, and then you follow it with parentheses, it'd be pointless. So they probably just took this because it was kind of an edge case that doesn't make sense elsewhere.
So $ over parentheses, that's the operator. That's, you have to have both of those together.
Yes, yeah, I believe if you had a space there, that wouldn't be template Haskell anymore. Yeah. And then quasi-quoters are basically a way of passing arbitrary text to a template Haskell function, more or less. So this is more or less a template Haskell function. The quasi-quoters, basically, the name of it goes between the open square and the bar, and then it lasts until the bar close square. And then this text is basically passed in directly, quoted, non-modified, into the quasi-quoter that can then process it and generate Haskell code from it. Yes?
So that text right there, is that a string or what is that data type of the?
Well, that would actually be, I mean, since you can't operate on that string from Haskell land, it doesn't really have a Haskell type. It's going to be a type from the parser that that GHC is going to use internally to keep track of it. But in our land, in user land, basically, you don't have any real type for it. It's raw text.
Any reason template Haskell is not enough? Why do we need quasi-quotes?
Quasi-quotes are actually mainly just used for examples here, because it lets you put the things in the same file.
Okay.
If you were using template Haskell, your arguments to template Haskell still have to be syntactically valid. This lets you have them not be syntactically valid, just raw text again. Of course, like I said earlier, template Haskell can load raw text from a file, but if you don't want to load raw text from a file, quasi-quotes are basically the way to do it.
So it's basically inlining.
Exactly. It's basically inlining, loading a file, and template Haskell. So this is a Yesod Hello World application. As you can see, we have our language extensions. We import Yesod. This is what's known as the foundation data type. I'll talk more about that later. Right now, it clearly doesn't look like much. It doesn't have any constructors which take any arguments. It doesn't even have more than one constructor. And the beef of this is make Yesod, which takes the quoted name of our foundation data type. And then we have some quasi-quoting here. And this is the parse routes quasi-quoting function. And this handles routing definitions. So I was planning on throwing you guys in before I explain some of this stuff, but I'm getting the impression I won't be allowed to do that. So to say a little bit more about this, this is basically mapping a path for your browser to a resource. So this is a resource constructor, and you're actually declaring it there. And then what parse routes and make Yesod do is it actually constructs that data type for you. So you can have multiple lines here defining multiple different routes. And it'll construct a sum type with your various routes all being part of the route data type for your application. And what this gives us is it gives us type-safe URLs, is the idea here. Because when we get to a little bit later, and we want to say put a link into our page to a particular resource, we specify it by our resource data type. And if that resource data type doesn't exist, you can't use it. So this lets us make sure that we're not creating dead links by making typos and things like that. Because the compiler is going to check it when it actually compiles this, and that will prevent us from creating those. Yeah.
That's a template Haskell function.
Yes. Sorry, I should have specified that, because this is the downside of having that top-level availability of not using the $paren, and that now it's not clear that that's a template Haskell function. But that's actually, I believe parse routes here is just basically turning this text representation into an internal data type representation that then goes to make Yesod, and then it actually generates the code itself. Yeah.
But
wanted to run this, the only thing we have to stack build is Yesod, right? Is there any other thing?
Well, the thing is, Yesod has a lot of dependencies.
37. Not crazy amount.
Okay.
Alright, I'll try it out.
Okay, sure. I mean, we're getting to our first exercise soon here.
It does something to data hello world. Does it rewrite that, or so like we see the data
Yeah.
hello world equals hello world?
It basically needs that because it's going to be defining some functions over that foundation type, basically. I'll get to that more later when I have examples up. And then, so after that, we have an instance, Yesod hello world. So we're instantiating a type class here, but as you can see, we're not actually defining anything in that type class. So
Nothing to define, there's no functions associated with type class.
there are functions associated with the type class, but the nice thing about the Yesod type class is they all have sensible defaults.
Oh, cool.
So basically, that's what's still giving us most of our application logic, or at least a lot of the things you can configure about our application, but they're just all sensible defaults right now. And we'll cover more about what some of the things we can configure later are. And then this is, most of our actual application's logic will end up in these handlers. And the handler basically defines a resource, how to respond to a resource request, basically. So in this case, we have this default layout thing I'm not going to talk about quite yet. And a quasi-quoter here that basically takes this and puts it into a data type that we use for talking about HTML, more or less. But I'm going to get to a lot more about that later. Yes?
Just last question for me. So that, I'm a little confused at the beginning. Are those import statements?
The first four?
All those languages?
So those,
Language fragments.
yeah, so these, how you include these is you specify a language pragma, or at least that's one way. You can also specify it at the GHC command line or in your Cabal file. So for the first few exercises, we're going to just have these in our file here, like this. When we get to the scaffolding template, those will be included in our Cabal file, and they just won't be floating around anymore because you end up with like more than this in most files, and it just becomes like, oh, we're wasting 10 lines on language pragmas.
So a language pragma is different than a package?
Yeah,
That's like
so
generation or?
rather, it's not even code generation. What a language pragma does is it enables an additional almost pass, or more than pass sometimes. It enables parts of the GHC compiler. So in order to comply with the Haskell standards, we, by default, don't offer all these extensions. But most of these extensions are really handy, so they package them away behind extra flags, which allows GHC to give you more features.
Okay, cool.
So they basically change the fundamental language, but in generally not entirely major ways. And yeah, it looks like this. I skipped that last line, sorry. So main, right, entry point. Warp is a web server because what Yesod is defining is the application. And what the abstraction being used in Haskell for applications and servers is something called WAI, W-A-I, Web Application Interface. And that defines a consistent layer between your application and your actual server or request system.
If you ever use WSGI,
Yeah. So this is kind of cool because you define your application, and then you still can switch out the web server that's running underneath it, however you want. Warp is basically the flagship web server. It's very fast. It uses very advanced, Haskell techniques to get lots of speed, and it uses GHC's ability to do like lightweight green threads off of ePol or KQ to get really good scaling. But that's, again, beyond the scope of this talk, so yeah. The other cool thing is that there are also things that aren't actually strictly web servers here that you can use for the WAI. You have things like, there's one which basically turns it into a desktop application. I've never played around with it myself, but apparently.
So it makes hello world a Y application, basically. All the native on.
Yes.
Could you
Basic, yeah.
Could you write your own, like, could you turn it into a Slack bot, for example, or something like.
Well, so the sort of thing. Well.
Like maybe it doesn't make sense to turn.
Yeah, at some point, Yesod isn't the right tool, right?
Yeah.
But yeah, I'm not sure if that makes sense to do that.
But
Or if it's possible. I'm not entirely sure.
And Yesod supports WebSockets and stuff like that, right? So
Well, Haskell supports WebSockets, and it doesn't restrict you from using as much Haskell as you want. So obviously, you could have this website eventually, contact Slack and do things to Slack, but it's still fundamentally a system that responds to requests with responses.
I'm saying, I guess what I meant was what Yesod supports WebSockets.
Yes. Yeah. Yeah. So, and there's also a really nice development server that gives you better logging and some other nice things and automatic rebuilds. Oh, this actually changes my talk more than I thought. So I wasn't going to use that because it really ran terribly on the Code.io machines. But for those of you who aren't on those, you may actually want to use that. So I'll talk about that in a second, I guess.
By the way, for people who are using their own machines, I installed Postgres, and Task 7 complied. So if you install Postgres, that's probably all you need.
yeah, on the Mac, just the brew install PostgreSQL and then.
Okay. But that's just people running it, on their own machine. If you're doing Code.io, that's fine too, and that's all set up already for you.
Brew install PostgreSQL.
Okay, cool.
All right. So this gives you, something, and the 3000 is running on port 3000, just to specify that. So, if you run that, you go on localhost 3000, it just serves you back a response. It's just the hello world from earlier.
Just anecdotally, I downloaded the repo and did a stack build in Task 6 about the time that we started talking.
Okay.
I'm at a point where I have a web server and
Okay, maybe people have better computers than I thought. I just got this new machine, really recently. It wasn't long ago, I was on, a 7-year-old MacBook. So maybe I just have a warped view of what computers people have.
No pun intended.
Most of my... No pun intended, correct. But, I have friends who are running, really old computers, too. And it won't work on that, really, generally. Anyway, I was going to, actually, this slide was supposed to be better, but I didn't get around to it. But we were going to do this exercise. So this is what you're starting with for task 1. It's basically the last example, the hello world example, but you got some more pages, and we're actually already using our type-safe links. And the idea here is you just basically add a page to this. You add a fourth page to this application. Now, it seems some of you are pretty capable of jumping on this yourself, but for Code.io people,
This is a different file.
this isn't task 1, it's task.hs.
So this is in
Task 1,
Task 1.
task.hs, yep. So, which people are using Code.io again? Okay. So have you signed up for Code.io then? Okay, and you've gotten into the class?
Yeah, I was in task 1.
Okay, great.
And I was trying to follow the instructions.
Okay, good. So the README and that.
Stack GHCI in the main.
Great, yeah, okay, great. Okay, good. I just want to make sure, because I hadn't heard much from the Code.io people. I want to make sure it was actually working. And were you...
I'm having good luck doing it local.org.
Okay, you're both doing... Okay, okay. So we got...
I'm in this task 5, trying to just go through each task, trying to get the dependencies installed. So,
Okay, but
but it seems to be going all right.
great, great.
We're
And
good, yeah.
anyone in the back... Oh,
No, I
Okay.
just, never mind.
anyone in the back row using Code.io?
Common that builds and runs in stack stuff. There's something like stack run or something.
So you're running locally. Okay, I'll bring this up now. So if people are running locally, you may want to actually use stack exec. Oh, actually, you probably don't want to do this, do you? So okay, I was gonna say Yesod devel, which is the development server, and I didn't give myself enough space really, but Yesod devel. Yeah, well, you don't actually need it. That is a dash dash, but that's just to specify that that's no longer options to stack if you actually had something that started with a dash over there. This is running the development server. However, to do that, you'll need to stack build build Yesod bin cabal install. I don't know how long that will take. Maybe that was actually the main problem. So depending on what you see there, if that was actually the main problem, I should have just told you. So to not do that, you can either do, this is stuff that's in the Code.io guide, the stuff after this line. You can do stack exec, or have you built it? So you build it, you do stack build it. I did not expect to be using this whiteboard. You can.
Inside a project or does it matter?
Yes, it does have to be inside the project.
Each project.
Oh, you mean, does this have to be in each project?
Yeah. Well, yeah, that one. Stack build. That goes to the.
That just goes into global, yeah. You don't, yeah. You might, something like that. Anyway, if you don't want to do the show development story, you can do stack build, stack exec task. Or you can also do, after stack build, you can do stack GHCI. And then just running main inside GHCI with a lowercase m.
I forget, what is the task of the first task?
Yeah, sorry. First task is you're just adding another page to this.
Another page.
Yep.
So it just cycles through what it already
Yeah, sure. You add a, yep.
This is what we're supposed to be typing in. Right?
Okay. So you're using locally, right? All right. You can try doing this stuff. Have you started that? Did you start that one?
I run this
Not
back.
yet. I'm going to start with build.
It told me the following targets packages were not found. Camel install and Yesod bin when I run this. So
stack employee says
Wait.
Yeah, that's good.
Oh,
No, look.
Stack builds Yesod bin cabal install.
Yesod without an E at the end.
Sorry?
Without an E at the end of Yesod. And cabal install has two L's.
Okay. Yeah, okay. So install. Okay.
Let's see. Okay, only 13. That's not bad.
Is
What?
there a way to put like another A inside the quasi-quoter? Like I want to have two different links on a page?
Yeah, there is.
That's super.
Why not give it a try?
Gavin?
Yeah.
Stack run task to fix this code.
This code works.
I was just running.
You're going to run it. I mean, you can run it. The goal is to add another page to it.
Oh, okay, got it.
Stack run just executes all that for you. So if you just use stack run, it should be.
There's a stack run?
Yeah, if you install stack run and just do stack run, it'll do stack build and stack.
Okay. So, yeah, apparently you don't need to do these two. You can just do stack run. I never used that.
build and exec.
Yeah, it does these two things. The stack run.
Okay, that's only if you want to do the non-development.
Yes, that
If you
is.
want to do the development, you still have to do stack exec.
Yeah.
Build them in there.
Yeah.
Is there an order to these things?
Oh, no, they're completely scattered about. You don't do all of these. You do like a random selection. I'm sorry. I'm going to number them, I guess. So,
Okay, stack run, you have to give an argument.
so these are both method 1. This is like method 2. This is method 3, which is one line.
Stack run.
Well, you have to install stack run. So it's
Oh, you need to install.
stack run, and then you can stack run.
Okay, just do this then. And then there's also, yeah, just do this then. Don't do the stack run. Too much work. The third option is running stack GHCI, which opens GHCI, the interpreter, Haskell's interpreter, and then it loads up all the libraries for your project. And then you can just run main. So this is actually closest to what I was planning on doing later, especially on Code.io, because we were going to do like reloads and stuff, and it's not too important. So does everyone know what they're trying to do here? Like, kind of the way to go at it? Yeah, great. I mean, that's the plan. I just wanted to.
In DHI main, is it
Lowercase.
stack DHI main? Is it :r to reload?
Yes, :r reloads.
Okay. And should we get any new output? After, like I made changes.
It should say that it's rebuilt the file. Oh, so you need to kill it with Control C. If it's in the guide actually, but yeah, you need to kill it for now.
So So I can't stack.
You can kill it and then you can control R to reload, like a call R to
Oh,
reload.
I see. I killed
And
it.
you just killed the GHCI, the process inside
Inside
GHCI.
GHCI,
Yeah, exactly. Okay, sure. I was even going to use Code.io to keep track of how many people had completed things. I had assessments in each one, so don't bother since almost like you might be the only person. Yeah. So
Installing locally as well. It's building.
you're just doing it at the same. Okay, that's such a good idea. I like that. And for now, at least, yeah, you never actually have to build off a previous exercise. So
You always stack build in each task by itself.
yeah, each task is individual. At the end, there's some building off of each other kind of deal, but I give you the previous kind of deal so that so people don't get behind if we decide we have to move on.
Maybe you cover this later. Is there a way to lay out your HTML and then insert it into the quasi-coder, like as a, or does it have to always be the quasi-coder? I guess we're gonna get to that.
We're gonna get to that. Yeah. Good question though.
I have my links. I'm just trying to make it nicer.
I know that feeling. Yeah.
Can you explain exactly what Whelan is doing?
We're getting there. I'm sorry. For now, imagine it's generating code to build HTML.
Okay.
And for things like this, it's automatic, it's generating code that generates the thing it needs to put in there. And this actually uses some high performance HTML building libraries.
That's fine. At a high level.
Yeah. Okay. Yeah.
You said develop stuff won't work for the first task, right? Because there's no development.
That's an excellent point.
Yeah, I just ran into that problem.
I had completely forgotten about that.
But there's some logging in the default one anyway, so.
Yeah, so because it just runs warp, yeah, it doesn't support any of that. I'm sorry. I just either do this or this for that.
It works.
Anybody have success with the first one?
Stack build?
Well, no,
Yesod bin? Yeah,
this
I
step,
did.
though, right? So this step won't work. They just brought up that this step won't. They just told me that this step won't work because I forgot that it won't work.
Which won't work? Which step?
This is so develop stuff, but this is another process that you should be using now. This or this.
Okay, no, I'm thinking you want to get the dev output.
It's not working with task one because there's something missing. So, but then the other task will work.
Your laptop went to sleep?
Yeah, I went to sleep. I need to turn it in presentation mode. Yeah.
If you run the
just
normal
making
way,
sure it
it
was
still logs
that-
your
that-
request.
I stepped on my cord at the same time, and I was like afraid for a second. Where's my cursor? There it is.
No, he likes it that way.
Oh, he likes that way.
Well, if you notice when he goes to the presentation, it's yeah.
There we go.
He's just taking this very seriously.
Yeah. No, see. I put work into this. I was here yesterday doing that. We rearranged the tables because this is a weird U.
Making a really bad joke.
Right now I have to jump back forward.
A lot of stuff is like triggered stuff.
Right. Yeah.
Okay, so this is basically no changes.
I'm fairly new. So
No. The idea is to add. So I should have written that down somewhere up here because it's in the Code.io guide. The task is to add another page to this.
Oh, okay.
Yeah.
So is there a significance to saying home R, page 1R?
Oh, the R? Yeah, I meant to mention that too. That's just resource. It's convention. Yeah.
So I'm really green to web programming. I got the page running.
Okay.
I have no idea what this means.
Oh, okay, yeah.
What's a resource? And what's a get? I don't know this.
Okay, yeah. Does the AHref make sense first? The AHref, these. Do these make sense?
Basically, all that means like this link is pointing to the other page.
Yeah, it makes this a link to that.
Yeah.
So these are the resource data types. So these basically become URLs.
Okay.
The idea behind the resources is both to prevent having invalid links,
Yeah.
because now it's mapped directly to these always, and the other way too.
Oh, so basically the thing up there makes sure that like the resources are embedded in the type system so you can catch errors.
Exactly.
Okay.
But it also allows you to change your the root of your site,
Yeah.
because a lot of times you actually want like not no relative links.
Yeah.
So what this will actually do is, right now actually the default instance in here will actually make your app root determined based on the request headers.
Right.
So it'll work no matter where it's served from, but you can actually specify where it's served from, make sure all the links go to there, but then you can change it easily in one place without changing links everywhere.
Cool. Okay, so that just embeds in the type system.
Yeah, so GET is a type of request. So there's a few different, it's an HTTP method.
Okay.
So it's part of the HTTP standard. There's several of these. GET requests, according to RESTful principle stuff, is they shouldn't cause side effects.
Okay.
But if you have something that does cause side effects, it's generally a post request.
Okay.
And that's something like submitting a form.
Is there a command to like stack exec and watch the file changes to Yesod and run again?
No. Sorry.
I can probably use Node on that.
That's what the Yesod develops for, but we don't have that set up for this one yet. So, sorry. Okay. How's it going? You're being quiet. Did you do the exercise already? Great.
I think, is there a way to say what? Just put whatever you want there in that page. We have the question.
Yeah.
Just add page 3. So you're only importing Yesod, right?
Yeah.
Which parts of the program are like built into the Haskell language and which are coming from Yesod?
Which parts are Haskell, you mean, versus Yesod?
Well, which parts are built into the language and which parts are coming from Yesod exactly? Is most of it all coming from Yesod? Or
Well, yeah. So.
I come from like Python, right?
Yeah, yeah.
Mostly used to like importing all your built-ins or
Right.
what you need.
So Yesod, I believe that Yesod package is actually kind of a meta package. It re-exports a bunch of other Yesod packages.
Okay.
So you don't necessarily. You can split it up more, I think.
Sure.
For this example, like Yesod's providing make Yesod, the parse routes, Whamlets, default layout,
Okay.
warp,
Okay.
and the Yesod type class with the instance line is putting, making links an instance of.
Sure.
The rest is
but
basically
you're actually
Haskell.
defining links as a data type yourself in this program, right?
Exactly, yeah. So that's your foundation data type again. That's the same as hello world was last example.
Okay.
And get home R, get page 1R, get page 2R. Those are just standard function declarations. They're not typed here, same with main, because I ran out of space on the slide.
Okay. Cool.
No problem. All right, so, sorry, what? Oh, great. Okay, okay.
For each task, what you're supposed to do? Is that like a slide?
It was in the guides
Okay.
on Code.io. I was expecting, I misjudged my audience, I'm sorry.
That's okay. So, is there a way, maybe, I don't know how.
You thought people were going to show up here prepared?
Well, no, the point was that Code.io would mean they didn't have to be.
Yeah, but that still requires preparation.
Less so than this.
To
Okay.
adapt to circumstances. I don't mind building this stuff. I'd rather learn how to build it than build some platform.
Yes, but the point is that stuff's easy enough to learn on your own, right? Like, charter parity.
Could not clean up old kegs.
I'm fairly, yeah.
When you're using that like quasi-quotes in a text editor, is there any text editor that actually supports it in terms of syntax?
I'm sure you could write an Emacs extension.
But there is no, you're not aware of any. Because for example,
I haven't seen anything. Because, I mean, you'd need an implementation of that for every quasi-quoter, and quasi-quoters are part of the libraries, right?
okay.
And then you're just including a whole bunch of different parsers for any other language or whatever.
So quasi-quoter can be different across different libraries.
Yeah, so Whamlet here is being provided by, because the stuff inside, right, it's just being passed directly into this kind of template Haskell function as raw text. You're, highlighting or whatever, would have to
what
know.
I'm saying is like to just like Yeah, okay, I understand. You could have different syntax inside there.
Exactly.
I mean,
You could have
because-
arbitrary.
Because right now it's coloring it in a funny way, because probably it thinks it's Haskell, or is it?
Yeah.
Why is it home? Why
Because
is
it's
home,
capital,
yeah.
right? Yeah,
It's
I
kind
know.
of like it's getting confused because of that.
Yeah.
What I'm saying is like if you could just treat it as a string. For example.
Yeah, just turn it off. I haven't seen that. Yeah. All right. So can I get like a show of hands? Who here has completed the exercise?
I just added another.
Yep, that was what the exercise. Great, great. Okay, do people, well actually first, if we take what? Oh yeah, the slides are online. There's a link, there was a link for the slides too.
Sorry, the exercise. What the exercise is supposed to be.
Okay, later I use Code.io less, first of all, so
Okay.
that's a little helpful maybe.
Okay. Maybe if you could just show that.
Yeah, I might,
Just show
okay.
that before the exercise on the screen. That may be good enough.
Okay, yeah, I think, yeah.
What do you mean that? What do you mean?
He means just like pull up the code. It's like Markdown on Code.io. Anyway, how are you doing, by the way?
I think I've got what I added here is third page.
Great.
Seems like I clicked through it. So
Great. Looks good. Yeah, man. Great. You signed up for Code.io as well? Are you going to? Okay. Okay. I just heard you ask for Code.io, and I was like, I hope you're not still like not being able to do anything. Okay. Look back around here. I'm gonna. Yeah. I'll bring them up next time. Okay. Yeah. Yeah. All right. So let's move on a bit here onto the next section. So I mean, I had this "what did we do" slide. Come on. Quiet down. Okay. We're gonna move on now. So yeah, congratulations. You modified a Yesod application. You already used a whole bunch of things. I mean, we talked about these more than I expected to by now because you're all inquisitive. But like I don't know if any of you like don't have much experience with monads, are afraid of them. But like there were already monads in that application. You just didn't know about them. If that makes you feel any better.
Identify them for us.
Sure. Handler. Okay. So those were. Oh, okay. So those were typed handler HTML. Handler is actually a monad, but I'll talk about that a little more later. So we're going to talk a little bit more about our content creation, right? So far we've managed to make some links. So let's talk about how that works, right? So we want to do more of in this kind of static like links stuff. Right now we haven't done anything that couldn't be a static website generator, which kind of defeats the purpose. So actually kind of separately than Yesod, but they work well together with Yesod, we have the Shakespearean family of templating languages. Hamlet, Lucius, Cassius, and Julius. Now, each one of these corresponds to HTML, and then we have two for CSS, I'll mention that in a second, and we have JavaScript. And these are the language that allows us to do that embedding of our type-safe links, for example. And if we continue on here, we have more forms of interpolation than just the type-safe links. You can take variables from your context. So if we define a variable before our quasi-quote is there, we can embed that variable here with this hash curly braces. So the character in front kind of specifies what type of interpolation it is. @ are the route interpolations. As you can see here, you got the hash interpolations, which is just the variable interpolations. And the cool thing about this is this isn't raw text embedding like you'll see in some kind of templating systems. There's actually, to do this, your variable has to be a member of a particular type class that gives it a function in order to convert that safely into HTML so that you automatically get HTML escaping and things like that. Yeah, something other than show. So I'm not going to get into that too in depth because, I mean, the nice thing is most things will have that for you. You don't need to worry too much about not having it available because all your basic types will have that already. Now, there's an extension here actually to our URL interpolation we're not going to really use it in this workshop. I wanted to mention it, but you can embed query parameters in.
I'm not sure what you mean by URL interpolation. So what would be replaced when you did Omar, the at curly?
The at curlies are being replaced with the text of the URL, right?
The actual URL.
Yeah, exactly.
Okay.
Yep.
So I guess that Homar was one of those things in the make Yesod, right?
Yeah.
So it was
So in our route definitions back there, I shouldn't keep on going back like this. It's basically taking this and then it's getting the app route to combine those together into a fully qualified domain name with a route on top of that.
However the person got to you, you'd see the whole thing. You said the
It-
domain name.
You see, yeah. So you can specify directly which domain names you link to, your root domain, but in the current setup here, it defaults to actually just determining that from request headers. So wherever they sent you from, you'll send it back to.
So these URL interpolations are currently within this application, right? So once
Yes.
they want to use the same kind of escaping and everything and refer to something in some other application outside somewhere, but part of the URL depends on something in here.
Well, if you're talking about having a separate Yesod application,
No.
okay.
Somewhere.
At some point, you can't type check text, someone else's website.
Can I use not type?
You can put in literal strings, obviously.
Escaping can become still though, right?
Of what though?
URL.
So if you use a myvar with some URL in it, and it's a string or text, then it will escape whatever.
What I'm getting at is
Oh, I see. So if this variable is a URL,
And there's
yeah,
some
so let's say
characters.
I'm going on to GitHub.
right, and it gives you back some request to find something,
And that URL depends on the GitHub username.
right?
And so if I just use a myvar, then I might be able to put whatever I want there. But if
Well, no, I mean, so even if this was a string, right, this is automatically going to escape things for you.
it is, okay.
Yeah, because it uses that type class to get a separate function to call to turn it into a safe HTML. Yeah. Now there's also template embedding, and this lets you put another template inside your current template. And this is, kind of the basis for getting to things like reusable page components. You want a footer or a sidebar or a header.
Can you parameterize the templates things that you?
You can have a function that generates a template,
Okay.
and you can parameterize that. Yeah. Because, well, this is actually more than just a variable here. This is actually, you can put Haskell code in there. Inside you have variable interpolation. Basically, it still just gets back a value and determines by the type what to call to turn it into a safe value for your interpolation. So Hamlet.
Can you go back one?
Yeah. Also, yeah, I maybe forgot to bring this up, but I kind of recommend everyone to download my slides, which were also linked in the Slack channel and in the bit.ly.
So what do you use for slides?
This is Beamer and Minted. It's about 2,000 lines of LaTeX. I spent a lot of time on these slides. They look pretty nice though, right? Except for, sometimes the coloring's a little weird because you don't have like Hamlet pigments libraries. I briefly considered writing them and then decided that was too much work. Anyway, done with this slide? I think so, yeah. So moving to Hamlet, which is the HTML templating language. It also has, so those interpolations are kind of shared between the various Shakespearean templating languages. Hamlet's the most advanced of the Shakespearean templating languages. It has some embedded logic for looping, pattern matching, specific cases, kind of things like that are handy. Now, the goal is not actually to put your application in HTML because that can be really pretty ugly. The goal is still to have most of your main application lifting being done by your handlers in actual Haskell code. So any code that's actually in the interpolations is not actually run in the handler monad. It's run in a more restricted monad. So you can't actually do all the same things that you could do in your handler. And that's just so that you don't have like crazy SQL queries inside your variable interpolations because that would be a bad idea. So this is kind of an example of what more complex Hamlet than what we've been doing looks like. So I mean, this is all kind of standard HTML stuff. This doc type tag allows you to generate the HTML doc type tag that starts your HTML document. We got our URL interpolation. Now, I know I said white space based, but this is kind of an example to also show that's limited. So since we had, not gotten a new line here, we actually have to close this tag because it matches that tag. Does that make sense? I feel like I didn't state that really. Yeah. We got our variable interpolation we talked about, and more link interpolations. This is kind of a quality of life improvement. You kind of put in the CSS shortcuts into the HTML. So that's short for ID equals body. And then we can just do dot page title instead of class equals page title. And you can actually do like dot page title dot page header or something or whatever, and it'll just be class equals that space whatever. So you got those sorts of things, and then we got some of the logic here where we have an if case, and you can check null friends if your friends list is null. This is from the Haskell book, or the Yesod book, not the Haskell book.
So can it also drop down to just regular HTML?
You mean drop back into HTML?
Well, let's say I wanted to actually say H1 class equals
Oh, you mean for like class and ID? Yeah, for that sort of thing, sure. But you're still stuck with the, if you want the features of Hamlet, you're stuck with the white space and no closing tag stuff, right? Which is, some people will hate, some people will love. And of course, there's also else if clauses that you can do. And then you have for all, which is a looping construct. So friends being a list of friend data constructors with names and ages, you can loop over them, and this will generate a whole, for each element of that list, generate a list tag with the name and then age years old.
So that stuff after for all,
Mm-hmm.
when name age, is that Haskell code?
Not quite, no. So the stuff in these isn't quite Haskell code like the variable interpolation is. These are even more limited. It's kind of its own little language.
So it seems like there's some control flow happening, like if else and all that.
Yeah.
What other fields are possible?
What?
What other fields are possible?
Oh, we're getting to that. Okay. Yeah, so you got control flow and you got this looping construct, pattern matches. We're getting to that in a minute after I cover some more about template interpolation. So this is kind of a way you would do template interpolation. If you have some content and then you have a wrapper that actually defines your HTML or head tag and stuff that you don't want to replace very often, then you can just, if it's the right type, if it's HTML, you just caret embed, and it'll basically just paste that in. So more embedded logic, right? So this is one, I'm not sure if this is very clear, but is checked and is read in this example would be variables from your Haskell land, Booleans. And then checked or style equals color red or HTML attributes, right? And those will only be in the tag, or only be applied to the tag if the Boolean is true. This is, getting into kind of web-devy stuff.
So what exactly is Haskell land right there? Is red?
Is read and is checked. So those would be like Haskell variables, which are a Boolean type.
Okay, and then what about that style and then checked? That's HTML?
Yeah, that's HTML. That's actually, I think style equals like CSS inside HTML, but yeah.
Okay, so you're basically saying check that bool.
And then if it's true, we get this special attribute. So this will say, this paragraph, if you had some text over here, will be colored red if is red is true.
Interesting. For multiple, you would just space, colon, next thing, colon, conditional.
Yeah, you can have multiple of these in one tag, yeah. You got a special construct for maybe values because they come up so often. You can say maybe name if maybe name is nothing, got the nothing tag, nothing is optional. You don't need it. You can just not have anything there. If it is a just, then you do the first one. If it's nothing, you do the second one. Yeah. Now there's also, we have the pattern matching like we kind of did on the for all here for maybes as well. Yeah. Then you have more full pattern matching with case. I actually really don't see that used very much. I don't see a lot of these things used very much.
You usually write functions.
Yeah, you usually try to keep most of your logic outside of your HTML. Yeah. And then this is one that's a case of, oh, I really love putting my my logic in my HTML. If you want to put really long expressions in your HTML, with lets you have some, this is obviously a fake example expression, but you can bind one big long expression, and so you don't have to type it out multiple times or have it run multiple times. With. All right, so Lucius is CSS templating, simpler than Hamlet. Basically, we have our interpolations like before, and then we have just a few niceties. So we got variable definitions, so we can say inside our CSS here, we declare a new text color variable, and then you can use it just like variable interpolation. And you got your URL interpolation, but you also got these nested blocks, which I'm just bringing these up because they're nice things to know about. They're handy. I'm not actually having you write any Lucius, so details about CSS aren't important if you don't know CSS. But yeah. Are there questions about this example? Oh, well, I guess one question. So I mentioned mixins on this slide. I don't mention them here. That's because I've also never seen them used. They're pretty newish. So they basically would let you do like if you have a bunch of those like browser-specific tags, I think you could do like some nice mixin thing where you can choose which one you want. I'm not entirely sure about the details. So I'll mention CAS just real quick. I've never seen this one used. It's a never CSS templater. It's the same as Lucius in every way, except for it's indentation based now, no curlies and semicolons. Now I assume this just isn't used because there's not a good reason to use it, and because people like to be able to copy and paste their CSS code. Right? Like who actually wants to write a whole bunch of CSS? And then Julius is the simplest. Julius just has the interpolations. It doesn't make a lot of sense to embed a bunch of Haskell logic in a full-fledged programming language that can do anything. So you just write more JavaScript if you wanted to have actual logic in your JavaScript, or you write more Haskell if you wanted actual logic on your server side. So yeah, you basically just got your interpolations. Yeah?
So this is interesting to me. So what exactly are you doing? This is JavaScript that I'm looking at?
Yes,
right
it
now?
is.
And we're actually filling that in with...
Yeah. Yeah, so this is really useful. I know we will talk about it in just a minute. Yeah, I'll bring that back up when I go talk about that thing. Yeah. I just mean the language is simpler. Like there's less features that the Shakespearean templates add to it.
But you could probably do all of this in
Yes, you could do all this in Hamlet. The point is that Hamlet has more.